So, graphing square root equations. Does this look familiar at all to you? It should look horribly familiar to you. Yes? Okay. I want to evil laugh right now when I look at this. Now, the one major difference is it didn't have a square root before, right? It had either a cubed over here, or maybe it had an F in the front, right? Everything else is exactly the same, though. But now we're going to apply it to square root functions. So, A, B, H, and K all mean the same thing that they did before. A is still a vertical stretch or compression, or what? Reflection. Yes? B is horizontal, same things. Stretch or compression or reflection. H, what's that? Horizontal shift. And K is a vertical shift. So that's either comforting that that's all the same, or it's scary as heck that that's all still the same and you thought you were getting away from it. Okay. So, before I go further on that, let's review square roots really quickly. If I wanted to solve for y here, I would take the square root of both sides, correct? And y would equal what?
5.
But not just 5.
Plus or minus.
Positive and negative 5. So when we deal with square roots, there's this plus or minus thing going on. Same thing if I had y squared equals x. I would square root both sides. And that means I have y equals plus or minus radical x. Now, someone in one of my previous classes today said, why did the radical disappear off this one, but not off this one? Well, if you can take the square root of the number, then the radical disappears. If you can't take the square root of it, like I can't take the square root of x because I don't know what x is, then the radical stays with it. Okay? Now, I want to show you something on my graphing calculator. I am going to graph y equals the square root of x on my graphing calculator. Okay? Does that look like it has any significance to you? Does that shape look interesting at all?
It's not really a straight line.
Okay. I do notice that there's some interesting errors right here, and we'll talk about that in a minute. Now, because of this plus or minus thing, I'm going to include the negative also. So I have y equals the square root of x. Now I'm going to include y equals the negative square root of x as well, so that I include both of those, and let's see what we get. There was the first one, and there's the second one. Now does it look familiar to you? It's a parabola. So it's only a parabola if I include both the positive and the negative. And when we're dealing with these equations, usually we will have either one or the other, but not both. We will either have the positive or the negative. So if I only have one of them, I only have half the parabola. But I'm still going to have a vertex. All right? I'm just only going to have either the top half or the bottom half. Now let's talk about all these errors over here. What kinds of numbers do you notice are having this error message? Negatives. Any idea why?
Because it can't be negative.
What can't be negative?
The number inside of this.
The number inside of the square root. You can't take the square root of a negative number because that would give you an imaginary number, right? And we can't graph an imaginary number on a real coordinate plane. It doesn't work. Okay? So that's why we have some errors on these negative numbers. So, in case you haven't made the connection yet, squareds and square roots are related to each other. Right? Okay. I've done my mind-blowing explanation for today. All right, so let's keep going. since it is going to be half a parabola, it has things in common with the parabola. Main thing being the vertex. FYI, when a teacher writes something extra large,
It's important.
it's important.
Yeah.
When your teacher underlines or bubbles or highlights, that means you got to know it. Okay? Actually, I should do the rest of it. You don't have to highlight. You just have to know it. All right, our vertex is going to be... Doesn't my highlighter look awesome up there?
It does. And the red.
It's like amazing. It's pink, but yeah,
I like it looks red.
it does look red. Our vertex is H comma K. Now we're familiar with pulling out H and K, right? Because we had to for inflection points with the cubics and things like that. Okay? All right. Over here. Domain and range I'm going to talk about a little bit right here. This is more for those of you that are really strong memorizers and you like things to memorize. That's great. I'm going to talk about it a lot more when I show you what it looks like on a graph. When your B value is positive, your domain is X is greater than or equal to H. When your B value is negative, your domain is X is less than or equal to H. If you tend to be one who can look at a graph and determine the domain better, then just at least get from here that X and H go together. All right? Range, when your A value is positive, your range is Y is greater than or equal to K. When A is negative, your range is Y is less than or equal to K. Again, if you would rather look at the picture, at least know that Y and K go together. Okay? All right, I'm going to skip this because I think it's confusing here. And I don't want to encourage you to memorize that because I think it's tricky. I think it's easier to get from a picture. So, let's go right down to our first graph. And we're going to graph the mother function.
I like that.
You remember the mother function?
I remember the mother function.
Yep. So, what would you say is my vertex? Remember that thing that I highlighted up above?
Your vertex is HK.
HK. So, what is my vertex in this case?
That one.
0, 0. There's no H, there's no K, which makes them both 0.
Yeah.
And when I have a vertex and there's an XY chart, I'm assuming the vertex goes in the
Center.
middle.
Okay.
And I'm going to fill in values around. Now, why is my XY chart sideways here when usually it's up and down?
I like it.
There is a reason, but at this point it's not important, so we'll just say that it fits better on the paper. Okay? Will you believe that reason for right now?
Can we say because that wants to be?
Okay, the real reason is because I thought, hey, if the XY chart goes this, or if the X-axis goes this way, why don't we make the X column go that way, so that way it actually looks like the X number line. Okay? All right, so now, since a radical, or since a square root is half a parabola, only 1/2 is going to give me valid answers. 1/2 will give me imaginary, the other half will give me real. So if I start with -2, can I take the square root of -2? Not for real numbers. It would give me an imaginary number, right? So -1, same story. Square root of -1 is imaginary. So from your vertex, you will either be able to get values on this side or on this side, but not both because it's only half a parabola. Can I plug in the square root of 1? Yep. Square root of 1 is 1. Can I plug in the square root of 2? Yes, but it's ugly. Right? Can I plug in the square root of 3? 4? Let's use 4. Because the square root of 4 is 2. Let's try and stick with nice numbers whenever possible. What would the next nice number be? 9, because the square root of 9 is 3. Now, you don't always have to do 4 points like I have there. I at least want to see 3 points, though.
So just use positive, not the negative side?
Not necessarily, because if there is a reflection of any kind, it might be the negatives that work and not the positives. Okay? So you'll just have to test and see. As soon as I got the -2, I didn't really have to test -1. I knew that was the side that wasn't going to work. Okay? All right, so let's plot those points. 0, 0, 1, 1, 4, 2, and 9, 3. Now here's where I have to be a little careful as I draw it in. Now this should look familiar because it is the graph that I just showed you on the graphing calculator. But which end was my vertex at? 0, 0, or 9, 3?
Wait, Vertex?
Where's my vertex? Isn't it at 0, 0? So that's my starting point. The other end is where it gets my arrow. Does that make sense? 0, 0 is your starting point. The other end is what gets your arrow. Now let's talk end behavior. What is this statement asking about? Left side or right side?
Right side.
Right side. What's going on the right side?
Y is going to
It's going up. It's not going up very fast, but it's going up. So eventually, it'll get really high. This is asking about the left side. Now what's interesting about this, there's no arrow on the left side. It ends. I don't need to talk about end behavior, about what's happening off the graph, because it's on the graph. I can see where it ends. So we only have to do half of the end behavior when we have half a parabola. Now again, don't assume that you're always going to cross out the left side end behavior, because if there's a reflection, it might be the right side end behavior that you're crossing out instead. Okay? Now, let's talk domain and range. X goes with H. So if I look at all of these X values, X goes left and right, correct? So is my graph going to the left of 0 or to the right of 0? To the right. And I used 0 because that was my H value. If it's going to the right, that's greater than or equal to. If my graph is going to the left, that would be less than. Left, less than. See what I did there? Okay. My range, I know. Y goes with 0 because that's my K value. And if I look at my 0 on my y-axis now, are we going up from there or down from there? Up. Do you think up is greater than or equal to or less than or equal to? Greater than or equal to. So again, if you are a memorizer, that's what I just explained. If you are a look at a graph kind of person, that's how you go. So? Okay. Let's look at the next one. What is my vertex? 2 and 1. We still have to change that H sign. So let's describe what's happening there. We have a shift. How? 2 to the what?
2 to the right.
2 to the right. And we have a shift 1 up. Okay? I'm going to put 2, 1 in the middle. Now, I'm not going to fill in all of my X values. I'm just going to fill in the next 2 to see which one's the good side and which one's the bad side. So, if I plug in 1, 1 minus 2 is -1. Square root of -1, that's the bad side. So I can't use numbers that are smaller than 2. I can only use ones that are bigger than 2. 3 minus 2 is 1. Square root of 1 is 1. Plus 1 is 2. What do you think is the next number I should use? Should I use 4? Because 4 minus 2 is 2 and I can't take the square root of that. 6, because 6 minus 2 is 4, I can take the square root of that. That's 2. Plus 1 is 3. So there's my 3 points, my vertex plus 2 others. Let's graph those. 2, 1, 3, 2, 6, 3. And which one was my vertex? The 2, 1 or the 6, 3? The 2, 1. So that's my starting point. And it's the other side that gets the arrow. So we didn't do any compressing or any stretching or any reflecting. All we did was we took the original graph and we shifted it 2 to the right and 1 up. So let's talk end behavior. First statement is asking about the right side because it's saying positive infinity there. What's going on the right side? It's going up. Left side is the side I don't need to talk about because I can see the end behavior. It's stopping right there. Now let's talk domain. X is related to what number? 2. And is it greater than or equal to 2 or less than or equal to 2? Greater than or equal to 2. Range, my y value goes with 1. Is it greater than or equal to 1 or less than or equal to 1? Greater than or equal to. Questions there? All right, let's turn the page. Okay. So, let's look at this guy right here. What is my vertex here? Still 2, 1, right? Which is the same as the one I just did. Same as the one I just did. So we still have a shift 2 up. I'm sorry, 2 right. We still have a shift 1 up. What else do we have going on now? -2 on the outside. What does that mean? That actually means 2 things. Vertical reflection because of the negative. And then the 2 means I have a vertical, what? Stretch of 2. So 4 things going on there. Does that affect how I set up my XY chart or anything? No. So I'm going to put 2, 1. I believe the less than 2 numbers are the ones that aren't going to work. So I don't think that 1 is going to work. 1 minus 2 is -1. There's my negative under the radical. That's the imaginary side. So I got to use the numbers bigger than 2. 3 minus 2 is 1. Square root of 1 is 1. Times -2 is -2. Plus 1 is -1. Okay. What's the next number I should use? 6. Okay. 6 minus 2 is 4. Square root of 4 is 2. Times -2 is -4. Plus 1 is -3. So let's plot our points. 2, 1, 3, -1, and 6, -3. And my vertex is which one? 2, 1, because that's got to be my starting point. Now, can I show you another way to get your domain that a lot of people do not connect? Look at your XY chart. Because we had to cross out this side right here, if I'm looking at just the X values, which X values worked? The ones that are bigger than or equal to 2, right? 2 works, 3 works, 6 works. The ones less than don't work. So what's my domain? X is greater than or equal to 2. It matches up with your XY chart. Looking from here, Y goes with 1. What was that? I am right. It happens every now and then. It's less than or equal to because all those Y values keep going below the 1. So that's another way that you can look at. I know, it blows some people's minds that it's all connected there, isn't it? Okay? So you can get it from the graph or the XY table or memorizing that stuff on the front page. Okay? Oh, I forgot end behavior. What's going on the right side?
Going down.
Going down. Left side I don't need to talk about because I can see the end behavior.
Yeah.
All right. This is the last one we're actually going to graph. Okay? What's my vertex? 2, 1. Right? Same as before. So we still have a shift 2 right. We still have a shift 1 up. And what else do we have? We have a B value of what? -2, not a half. Remember, B is just the denominator. So I have a horizontal reflection and a horizontal stretch of 2. Remember, even though that looks like 1/2 because B is 2, that makes it a stretch. Now, I have a horizontal reflection, which means that instead of going this way, it's going to be going that way. Because isn't that a horizontal change. So that means I actually want my vertex a little bit further to the right in my XY chart. So I'm going to put the 2 and the 1 right there, because this time it's going to be the numbers bigger than 2 that aren't going to work, which should say something about my domain. Because 3 minus 2 is negative 1, correct? I'm sorry, 3 minus 2 is positive 1, times negative 1/2 is negative. There's my negative under the radical. So, can I use 1? 1 minus 2 is negative 1. Negative 1 times negative 1/2 is positive 1/2. It's positive, which is good. 1/2 is no good. So let's do 0. 0 minus 2 is negative 2. Negative 2 times negative 1/2 is positive 1. Square root of 1 is 1, plus 1 is 2. Any guesses as to what this next number is going to be? It's got to be negative, because I've gone through all the positives. Negative 6, I heard? Because negative 6 minus 2 is negative 8. Negative 8 times negative 1/2 is positive 4. Square root of 4 is 2, plus 1 is 3. So let's graph this guy. Negative 6, 3, 0, 2, and 2, 1. Which one is my vertex? 2, 1. So that's my starting point, and my graph is going this way. Didn't I suggest that up here? So, end behavior. What's going on the right? It's stopping. I can see it. That's the one I'm crossing out this time. What's going on the left? It's going towards, it's going up or down? Left side is going up. Domain. X is what?
Domain X is
It's related to 2. Is it greater than or equal to 2? Or less than or equal to 2?
greater than.
Less than or equal to. It's going to the left for less than. And if I look up here, all of the X values that worked are all smaller than 2. What about my Y values? Greater than or equal to 1?
Yeah.
And so there we go. Okay? All right. I do have a couple more minutes. I'm going to hold off on this one, and I'm going to go to this one. I have enough time to finish this one for you. I promise. It's not that long. Okay? So bear with me. We had a question like this on a previous test.
I remember that.
Okay? Where you had to write the equation of this, and a lot of people struggled with that. Now, in our equation, we have A, B, H, and K. 2 of those letters should be super easy to find because of my new vertex. What letters does that give me? H is negative 3 and K is negative 4. Now I'm going to do that box thing. Remember that? Here's the parent function. 0, 0 is the vertex, and the next point is directly up 1 and over 1. And if I make a box right there, that box is 1 unit wide and 1 unit tall. If I do the same thing here, I take the vertex and the very next point, and I make a box. 2 boxes together, I'm calling it 1 box. How wide is that box?
1 wide. 2
Isn't that the same as the original?
Yeah.
Which means that horizontally, there's no change. Which letter is horizontal?
B.
B. If there's no change, B is 1. A is vertical. This one is 2 high, this one is 1 high. So what's A? 2. Now, there is one more difference that I have to take into account, and that is the fact that the end behavior here is going to the right, and here it's going to the left. So we have a reflection. Is it a vertical reflection, meaning A has to be negative, or is it a horizontal reflection, meaning B has to be negative? B has to be negative. So let's plug that into our equation from the other side. Y equals A radical B. That would be 1 over negative 1. What does 1 over negative 1 become? Just negative 1. And after B, you always have to put parentheses there. Okay? So, X plus 3 and then -4 hanging out there. Okay? Okay, so some classes I didn't get to this example, but I want to make sure to put it on this video. So, all right, so describe the transformation. Well, the first thing I can see, I always look for H and K first. Since H is +4, we have a shift 4 to the left. Because remember, if H is -4, this really represents -4, we have a shift to the left. We also have a shift 7 down. Since K is negative, that means down. Now I'm going to look at my A and B. Now A means I have some things going on vertically. First off, A is less than 1. 2/5 is about 0.4. That means I have a vertical compression of 2/5. Since it's negative, I also have a vertical reflection. We got all sorts of craziness going on here. And then my B value is -3. So with a B value of -3, I have a horizontal reflection because of that -3. And then do we have a horizontal, do we have a stretch or a compression? Now let's think about this. If 1/B is what we get here, 1/B is in the formula, this is what's in that place. So if 1/B equals -3 for this example, if I wanted to know what B is, I would have to multiply by B. So 1 equals -3B. Divide by -3. And guess what? B is -1/3. So do I have a stretch or a compression? I have a compression. A compression of what? 1/3. Okay? Now, sketch a graph to help answer these. Well, my vertex I know is H comma K, so that's +4 comma, I'm sorry, it's -4, -7. So that's good to know. End behavior and domain and range. Let's think about this for a minute. Here is our parent function, goes like that in general. We have shift, 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 shift. Compression and stretching is not going to change the way that looks at all. So my parent function goes up and to the right, and it doesn't really matter where my vertex is, but it does matter if I'm going to stretch or compress this. It's not going to change what direction it's going. Stretching it, compressing it, vertically, horizontally, it's not going to change the direction this arrow is going. The only thing that's going to change that is a reflection, and I have 2 of them. Since I have a vertical reflection would flip this guy upside down. So if I have a vertical reflection, I no longer have the parent function, I have something that's flipped upside down. And if I have a -B value, that means I also have a horizontal reflection, which means that it not only had to flip down, but it also has to flip to the left. So that means that my graph would now be going this way. So the final graph is going to look like that with a vertex of -4, -7. So in knowing that, I should be able to talk about end behavior. The right side, there's nothing going on the right side, so I can ignore that one. It's the left side where I have end behavior, and it's going down. So I'm going to fill in -infinity. As far as domain is concerned, my x value is concerned with -4 because that's the h value. And since I'm going to the left, that means we would have less than or equal to -4. And my y value would be in reference to k, which is -7. Since we are going down instead of up, we would also be less than or equal to -7. Okay? So again, sorry I went out of order there. Wanted to make sure to get all that in this one video. The homework is out of the book. Please remember for numbers 1 through 9, I don't know that the instructions in the book say to put a graph in there, but I need you to put a graph in there. All right. Happy studying.